We're going to be estimating quotients again, and this is just an extension of the lesson we did yesterday. Basically the same things. We're going to be using some bigger numbers this time, so we may have to add a couple extra place values, but it's really the same thing as what we did yesterday. So, okay, on the first one, problem number 1, I'm going to take 33 and I'm going to divide it by 8. So I go to 8 on my multiplication chart. I follow it over until I find a number close to 33. Okay, and 32 is very close. So we're going to say 4 times. So I'm going to put a 4 directly below my my 33, and I got 2 place values there. So that's going to be 400. That's a bad 0. 400. Okay, problem number 2. Okay, I'm going to take 29. I'm going to divide it by 7. Take 7 on my multiplication chart. I follow it over and I'm going to find a number close to 29, and 28 is really close. So that's 4 again. So we put 4 under the 29. I got 2 more place values to account for there. So that's about 400. About 400. Okay, problem number 3. 55 divided by 9. Okay, go to 9 on my multiplication chart. I follow it over until I find a number close to 55. 54 is really close. I follow that up, and my answer would be 6. So I put a 6 under my 55. I got another place value there I'm accounting for, so that would be, that's 60. So 552 divided by 9 is about 60. Okay, next problem, problem number 4, 77. Okay, now if we look at 77 and we try look at 4 on our multiplication chart, we're not going to see 77 unless we have a really big multiplication chart. So instead of using 7, 77, I'm just going to use 7, just the digit, the first digit right there. And I will find that a number close to 7. I'll follow that over. I go to 4, and I've got 8 on my multiplication chart, which is really close to 7. And that goes into it twice, right under my first 7 in the hundreds place, and I have 2 more place values to account for there. So that makes 776 divided by 4 close to 200. Okay, problem number 5. Okay, 20 divided by 5. Okay, that's easy. I know 5 will go evenly into 20 4 times. Okay, and I have 2 place values to account for there. So that's 400. 28 and 3. Okay, look for 3 on my multiplication chart. I go over, and I got to 27. 27 is really close. That's 9 times. So I got 9 under my 28 and another place value to account for there. So that means 281 divided by 3 is approximately 90. I'm sorry. Okay, this problem right here, when estimating 1,320, why is rounding not a good strategy? Okay, on this one, and they're talking about, okay, say for instance, if I was to take 1,320 and round it, that would round to 1,000. And 6 would round to 10, so I divide that by 10. Okay, and when I do that, if I divide 1,000 by 10, my answer would be 100. Okay, and let's check that compared to what it would actually be. So if I take my calculator right here, and I go ahead and 1,320 divided by 6, what's it equal? Equals 220, and that's way off. My estimate's way off. Let's go ahead and try using using the strategy that we have been using. So we got 13. And we're going to divide that by 6. We find 6 on our multiplication chart, and that looks like it's 2 times. 2 times, so we go ahead and put a 2. And I have 2 more place values to account for. And my estimate right there actually is 200, which is very close to what the actual was 220, so that does work. But rounding wouldn't work real well in that one. Okay, when dividing a 4-digit number by a 1-digit number, how many digits can the quotient have? Okay, and you can see on some of the problems that we've been doing, we've got some 4-digit numbers here. we have a 4-digit number there, and it has 3 digits in its quotient. We have a 4-digit number here, and it has 3 digits in its quotient. But I think it could have more than that. I think it'd have more than that. Say, for instance, if I had a smaller divisor, and I had a 4-digit number. Say, like if I'm doing 6,428, I'm going to divide it by. One of the smaller numbers we can divide by is 2. So we're basically dividing it by 2. And let's see what that actually turns out to be. Okay, if we use a strategy that we've been using for estimating, okay, 2 goes into 6. 2 goes into 6 3 times. So there'd be a 3 there, and then I'd have zeros right here to account for the other. So I did end up with a 4-digit quotient right there. And let's just check with the calculator, make sure I didn't make a mistake, or see if it's not off by quite a bit. Clear that. So I got 6,428 divided by 2 equals 3,214. So we can have a 4-digit quotient when we're dividing. Okay, but you're not going to have anything larger. You're not going to have more than 4 digits. Okay, if you're, for instance, doing a multiple choice quiz and you have an answer choice that's larger than 4 digits on a 4-digit dividend, you know that's not right. We can go ahead and eliminate that automatically. So 4 digits is the most you're going to have whenever you have a 4-digit dividend, if you're dividing it, the quotient, the answer. Okay, let's go ahead and move through the rest of these, and let me erase some of this so I can have some more room on my multiplication chart to do some work there. Okay, and we'll try to move through this a little bit quicker. Okay, 77 divided by 7, and we know our 11s really well, so that's going to be 11, and one place value would end up being 110. Same problem right here, 77 divided by 7. That's 11, and then I have 2 more place values right there. And there right there on that problem, we end up with a 4-digit quotient. Okay, 56 divided by 9. I think I know what the answer to that is. Let's go ahead and check it. 9, follow it over, follow it over, follow it over. 54 is really close. That ends up being 6. That ends up being 6. And 2 more place values to account for right there. So that's about 600. 53 divided by 6. And go to 6 on my multiplication chart. I'm going to follow it, follow it, follow it. And 54 is really close. That's 9. And I have 2 more place values to account for right there. And that would be 900. Okay, 6. Okay, we're kind of getting the habit of underlying the first 2 digits, but on that one, I bet you if we looked at our multiplication chart and we follow it all the way over, we're not going to come up with any number close to 64. So we'll just do 6. And we know that 3 goes into 6 twice, and I have 2 more place values, so that's 200. This one, 39. 39 divided by 8. And we'll go ahead and knock that out really quick in our head. We know that 40 is really close to that, so that's going to be 5. We'll do it on the, since we're here. Maybe not everybody knows that. So we take 8, and we're looking for 39. 30 and 39. 40 is really close, and just like we said, 5. And I have 2 more place values there. The 5 and the 8 are holding a place value. So I'm going to put zeros there for my estimate. 3,958 divided by 8 is about 500. Okay, 49 divided by 8. Go to 8 on my multiplication chart. Follow it over. And I got 48 right there, which is very close to 49. And that's 6 times. It will fit in there. 6 and 1 extra place value, so that gives us 60. And we got the same problem here, 49 divided by 8. And that's going to be 6 again with 2 place values to account for, so 600. Okay, we knocked out the first page. Let's go ahead and look at the second page. Move it up there. Okay, and we're going to work on the even problems. I just knocked those out there because my multiplication chart was covering those up. But we'll go ahead and do 22. Okay, number 22. In 1999, an 89-year-old woman walked 3,055 miles across the United States. She walked about 9 miles each day. About how many days did it take her to walk across the United States? I want to go ahead and box that question in. Okay, one thing I want to pick out in that question is the label for my answer on this question is about how many days did it take her to walk across the United States. So my answer is going to be in days. So I'll go and write days over here, so it's going to be in my answer. Days. Okay, and we're going to circle some important information. So she walked 9 miles each day, and it is 3,055 miles across the United States. Looks like a division problem to me. We'll talk about the labels though too. Got to underline that label and underline that label. So it's miles and miles and days. Okay, and this is an example. A lot of times if we have the same label in both our problems, in both parts of our problem, a lot of times that's going to tell us that's either a subtraction or addition problem. But you can see in this one, my answer is in days right there. My answer, the label for my answer is going to be days. So in a for instance like that, we usually want to look at all of our labels. Okay, I got miles, miles, and days. Since there's a difference there, I have miles, miles, and days. That tells me it's going to be a multiplication or division problem. And like the title of the worksheet, it's a division worksheet or quotient. We know it's division, but late in our next unit we go to, we're going to have questions with addition, subtraction, multiplication, and division. So we're not really going to be able to tell just by the title of the worksheet what operation we're going to use. So on this one, we figure out the total is 3,055, and we're going to divide that by 9. So 3,055 divided by, my division symbols look sort of like subtraction symbols if I don't work it a little bit, and divided by 9. So I'm going to do 30 divided by 9. 30 divided by 9. 9 on our multiplication chart. 27 is really close to that. So that's 3. And 2 more place values to account for. So it took her about 300 days to walk across the United States, almost a year to walk across the United States. And also, something I failed to talk about is there's some other numbers up there. Probably not going to get fooled by the 1999 because you know that's a year. But sometimes students, might want to take into consideration the 89. It doesn't matter how old she is. It doesn't really affect how many days it took her in this problem. So let's go ahead and look at the next even problem. We'll look at number 24. Okay, 8 students can fit at one cafeteria table. About how many tables are needed for 231 students? And does your answer make sense, and how do you know? Okay, but what we're trying to find out is, this is what we're trying to figure out. About how many tables are needed for 231 students. So our answer is going to be tables. That's the label for our answer is tables. I'll write that over here. Tables. So once we get done, we need to figure out how many tables. Okay, I have 8 students will fit at one table. Okay, I'll circle that's important. And this is important, 231 students. That's what we're trying to figure out for. We're talking same situation. We've got students again and students again, but our answer is going to be how many tables is it going to take. So we got students, students, and tables. That tells us it's either going to be a multiplication or division problem. And since we have the total number of students and we're trying to figure out how many tables, it's not going to take more than 231 tables. We know that. So it's a division problem. So I got 231 divided by 8. So I'm going to look at my multiplication chart, which I'm losing right here. Look at my multiplication chart, and I find 8 is my divisor, and I'm going to try to find a number close to 24. Or close to 23, I'm sorry. And that is 24. and that goes 3 times. So I've got 3 right there and 1 place value to take up. So that means it's about 30 tables. It's going to take about 30 tables to seat those 231 students. Okay, and the last problem we're going to talk about is, okay, it is estimated that the average American uses about 650 pounds of paper per year. About how many pounds of paper does the average American use each month? So, okay, important information. Okay, well, the question, we box in the question, about how many pounds of paper. So our label for answer is going to be pounds. Okay, does the average American use each month? Okay, we need to know 650 pounds, and the other number that we're going to use for this is each month. Each month. Okay, so we know that there's 12 months in a year, so our problem is going to be 650 divided by 12. Okay. If I use a strategy that we used before, we'll try it out and see how it works. And since 12 is our divisor, we've got 12 as our divisor, and we're going to see how many times 12 goes into 65. Okay, take 12, we follow it over, and that's close, and that ends up being 1, 2, 3, 4, 5 times. So we'll say 5, and got 1 place value. So we're saying about 50 using that estimate. Okay, we'll try another strategy, and this is something different than we've done before. Okay, we're going to take and round our divisor. Okay, we'll round our divisor. So if I round my divisor, I'm going to round my divisor to 10. And I'm going to leave my dividend the same, 650. Same problem, just I rounded the dividend. Okay, and dividing by 10 is just as easy as multiplying by 10. And whenever we multiply by 10, we add a place value. So say, for instance, if I was multiplying 650 by 10, we would add another place value, so we'd end up with 6,500. But when we're dividing by 10, we do just the opposite. You just take away a place value. So there's a lot of different ways. Once you get in the upper grade levels, they'll show you something similar to this. You'd be 650. I'm sorry, can't write. 650, and we say, just like we said already, if the decimal's not inside, it's on the right. So the decimal's right there. I'm getting a little bit outside my range here. Okay, and if I take away place value, I'm just moving my decimal right here. So that changes the number to 65. And that's basically what we're going to do this. So 650 divided by 10, you take away a place value, and the answer is going to be 65. And that gets us a little bit closer to the actual, I think. We'll see. This is using one method. This is using the method where we just rounded our divisor. And I'll get my calculator back. Okay, and we'll do the actual 650 divided by 12 equals 54 and just a little bit, 54 and a little bit. And we came up with 50 here. We came up with 65 here. And you can see still the first method that we used got us a little bit closer. This is probably a little bit easier. We can come up with our answer probably a little bit quicker whenever we're multiplying and dividing by 10. And in science, that's the reason they're saying math and science. In science, we always like to multiply by tens, hundreds, and thousands. So this will give you a chance to look over the lesson. This is what we're going over tomorrow in class. So go ahead and review this lesson, and you can, as you're reviewing it, you can look at some of the other questions and kind of see if there's some things you want to think about a little bit on those questions before we do the